All right, great. I'm going to talk a bit about EasyBuild for bioinformatics as a wish list from UPPMAX. We're not really an EasyBuild shop. We have an EasyBuild tree in place. We install a few things with EasyBuild, but we have thousands of modules and versions that we've installed on our own. And we'd like to start using EasyBuild because we're going to be supporting users more on a different cluster, as well as our own and multiple clusters, and using something like EasyBuild would be much easier to do that. About me very quickly, I have a bachelor's in computer science and I spent 9 years doing compiler internals in industry, but I decided biology was better. So I did plant biology, I did field work, lab work, I have a PhD in plant biology, but then bioinformatics just pulled me back in. And so my position, I'm currently 50% biologist at the Evolutionary Biology Center at Uppsala University. I work with projects in a number of different contexts. Bioinformatics help, but also just from pre-grant proposal all the way to data archival. And I'm also 50% working at UPPMAX doing many different forms of bioinformatics support. So I have a good background to say that bioinformatics is very different. Okay, traditional HPC for bioinformatics. Okay, this is not really an exaggeration. Okay. Have we measured this? Yes. We published a paper in 2018 that shows, of course, and this should be familiar, traditional HPC is relatively few well-established tools with high compute expertise among users, whereas bioinformatics expertise, a wide variety of areas, many tools, widely varying user and developer expertise, many more PIs and users, much more scientific impact, and especially impact per core hour, okay? It's extremely rare to have a bioinformatics project that's using even 50,000 hours a month, even a few months a year, okay? But since 2010, when we began supporting bioinformatics explicitly at UPPMAX, we've seen huge growth in unique PIs, in software installations and updates, in tickets and tickets per user. So this data ends at the end of 2016, but the green is this is projects, and the green here is unique PIs, okay, whereas the red is traditional HPC, okay? Same with software installations and updates, and then this is through data 2021. The red is life science PIs, so the trends continue after the end of this paper. Just quick profile, there's very few multi-node jobs in bioinformatics work. Most of the jobs are single core and partial node jobs, okay? So support in Slurm for allocating single cores and partial nodes is extremely important. Long run times, 7 days or more. We have a cluster, an older cluster, a Sandy Bridge cluster that's specifically set aside for jobs that are 30 days or longer. And I think the current record there is something like 85 days. Bioinformatics jobs typically use high RAM per core, and they're low efficiency in terms of the way we would traditionally measure CPU usage. So this is like traditional HPC projects in terms of cores busy during a job. And this is NGS projects, okay? How do bioinformaticians use software? Typically, the pipelines that we use many different heterogeneous tools. They're busy sometimes, they're very busy on a single core sometimes, they're very busy on multiple cores sometimes they're IO bound, sometimes they're memory bound. Lots of different parts to one pipeline that a user thinks of as one job. And these pipelines also often support a lot of user-driven swapping and experimentation. So we don't just install a pipeline that's fixed and someone just runs it start to end, okay? It's not a well-defined job. There's typically a lot of, well, does this work? Do I have to switch to that? There's a lot of different swapping and even taking one aligner out and sticking another one in, maybe this one works better. And so the emphasis is on data flow and interchange and interconversion, not on CPU performance, okay? Among bioinformatics developers, there's an extreme lack of release engineering, okay? And this is a huge problem that truly needs to be solved. Anybody who's dealt with bioinformatics software in any sort of deeper way, or even in a very shallow way, knows how true this is. Nevertheless, some tools have traditional provisioning, okay? These are the tools that we see in EasyBuild now. Okay, tools that use auto tools, that use CMake, Some tools nicely provide pre-built, sometimes static binaries. That's all very, very helpful. But these tools are the exception, okay? And it's very nice that there's a lot of bioinformatics tools in EasyBuild, but there's a lot of stuff that users are asking for that isn't there. There's a lot of usage of PyPy and Conda, okay? And Conda discipline is often non-existent, okay? And I'm sure that we could all complain for the entire rest of the week about Conda for a variety of different reasons. And we have many complaints. Again, this extreme lack of release engineering, when you mix it in with Conda and the fact that Conda discipline is basically non-existent, things get really, really gnarly. It basically becomes attempting to do any sort of replication, basically becomes the software equivalent of, well, if you do it on my lab bench using my pipettes with my centrifuge and my sequencer, then it will work for you, okay? And Conda encourages this. It's extremely frustrating that an install 1 week to the next that you believe is the same is not the same, okay? It's extremely frustrating that Conda environments age so that it becomes impossible to recreate a Conda environment. How do we get across to users that the best thing to do is to blow away your Conda environments like once a month and rebuild them in order to, so again, I don't have a week to talk about this, okay? There is increasing usage of containers. Now, Conda is very nice for provisioning bare containers. And so we are seeing more projects that are providing containers, in particular Docker, but we don't allow Docker on our cluster, so we're running these under apptainers. Pipelines, such as SnakeMake and such, are becoming of increasing usage. These pipelines, it's very nice for the end users, and a lot of bioinformatics tools are actually cobbled together from many different pieces. The issue, so you get things like SnakeMake rules, like a particular SnakeMake rule, which is sort of like a make rule, can say, okay, to run this rule, run it within this Conda environment, or run it within this container. And what you end up having is a pipeline that to the user is just one basic start to finish analysis, may end up using 4 different versions of SAM tools and 2 different versions of BLAST and all sorts of stuff because of the various things that the different rules are requiring. Now you can say, well, I use this, but there's no logic behind the fact that all these different parts are being used. Often users are doing absolutely zero release engineering on their own when they're sort of cobbling these things together. They're just relying on what the developers have provided, which again, has absolutely no release engineering to begin with. So bad release engineering using bad release engineering squares the problems. So what do we at UPPMAX want from EasyBuild? Well, being consistent with tool chains is very rarely necessary, okay? Almost everything that we do is integer, and when it uses floating point, it's using something like GMP or MPFR. Sometimes these things, of course, have their own pipeline dependencies, but mostly we don't need tools to be built consistently with pipelines, okay? So for example, okay, I would like greater support for isolation, and seeing that use of RPath and EasyBuild 5 is great, because it's extremely typical in our environment for example, a user to want to use SAM tools 1.20, which is the latest SAM tools built with, on our end, GCC 12.3.0, could be built with the most recent toolchain, but it's swallowing output from BWA 0717. There was a new BWA release just a couple weeks ago, but a new version hasn't been released since 2017 until just recently. And that would have been built with whatever compiler we used in 2017. And there's absolutely no reason why there should be any sort of conflict between using BWA and SAM tools, even though they're built 7 years apart, okay? They could be built with completely different compilers, all that sort of stuff. One advantage here is that these are also very well release engineered tools in particular, okay? These are tools that you find in EasyBuild right now, okay? And so it's very easy to use these tools with RPath support, depending on different, GCC libraries and stuff, and it all works just fine. It wouldn't work if we were having to load EasyBuild modules to provide LD library path or something like that, okay? It only works when you have good RPath support. And so I'm hoping that RPath support that exists in EasyBuild is sufficient to do this, I'm wondering also if it's possible to perhaps have a post hoc tool, something like an EB isolate command, which can go in and try and like, well, what are the dependencies here? Can I actually, can I pluck this tool out from its tool chain and make this be an independently loadable tool? Okay, so that instead of having samtools 1.20 toolchain suffix, I can do EB isolate and it just becomes samtool 1.20, something like that. The second thing related to this is being tied to interpreter versions is rarely necessary. We talked a little bit about this in a question that I asked Alexander, that Alexander answered when I had a question for somebody else yesterday. Python virtual envs make it very easy to run different tools that are using different Python versions. It's extremely easy to do, and avoiding using Python path means avoiding a lot of different problems. I don't care if cutadapt is using Python 3.8.7 and some other Python tool is using Python 3.11.2 or something like that. I can have both those modules loaded, running fine, as long as they're running within virtual envs, or Alexander had mentioned EB Python prefixes, and maybe that's another, whatever works to allow these things to isolate, that's fine for us. But it doesn't make sense for me to have to, if I install a new tool with a new Python, having to reinstall all my old tools with a new Python. And the same sort of thing applies to any sorts of inner tool chain dependencies or conflicts or something. So I've said what I wanted, but what can we give? Okay. Well, we intend to create easy configs and easy blocks for all of our builds. Okay, this is just basically something that we have to do. And the hutch, okay, so some well-engineered tools are already in EasyBuild. So there's a lot of stuff we don't have to have there. I'd still like to have things like removing tool chain dependencies and stuff from those to the degree that's possible. And I know the hutch has a GitHub repository of a number of different easy configs. Some of those are now quite aged, but I think they do provide some places that we can start. We have a GitHub repository that contains our very aptly phrased encoded suffering. Okay. So here, this is readmes and scripts. It's not always pretty. Sometimes we forget to update the readmes after we do an install. Sometimes the readme still contains the dumped history that we appended to the end of it. But basically, we have a lot of these install methods already there. So I think we have a good basis for creating easy configs as we need them. Another thing I noticed, that I'm not going to be here tomorrow for this talk, but we've already started using data modules. Okay. So being that data modules are primarily loaded as a dependency, they provide environment variables and sometimes extensive help. So where I would have put help about certain data sets in the module that uses that data, instead I put it in the help for the data module itself. Many data sources are well versioned, PFAM, for example, and many others. Where they're not, we use, and they're haphazardly updated, we use, standard year, month, day versioning, or latest when updating is frequent. For example, BLAST 2.15.0 plus loads our BLAST databases / latest module. Okay, this is updated on a cron script every 2 weeks. It's actually the BLAST database's latest that sets BLAST-DB, which is the standard variable that BLAST uses to look for default databases. And so our ongoing concern, given that we're dealing with a huge number of modules, is that, how do we manage old software? Thinking back to my BWA 0717 issue, where the tool hasn't been updated since 2017 and hasn't needed to be. How do we manage that with reasonable life cycles? If we're having a 3-year sunsetting of tool chains that's coming up in EasyBuild 5, for example, does that mean that basically once we build an older module, is the clock ticking, and at some point we'll have to rebuild it in a new version to keep it running? These are things that I'm not quite sure how to solve them. One thing I do know is that while we've talked about having like a UPPMAX in a can, a singularity wrapper that provides sort of an UPPMAX environment, but you can't run singularity in singularity. And so, if you start using singularity containers and snake containers, things very quickly will not work. So we want to have an actual native build solution. And so we're, over the next year, going to be doing a lot to do this, because we really don't want to build on the multiple systems by hand the way we're about to start doing. So I think you can probably pre-schedule me for a much longer talk next year at the EasyBuild user meeting. But anyway, that's our basic concerns. I've seen a lot of nodding and stuff of people here in the room. Maybe a lot of people still perplexed at the idea of bioinformatics being done in a big way by extremely naive users that constantly refresh every year with a new set of extremely naive users.
I'm certainly not perplexed, and about a third of all the software that EasyBuild supports is in the bioinformatics realm. There's a reason for that. There's just a lot of stuff out there. Yeah, I don't think we have time to really go into the details of Q&A here, but you'll be around for dinner tonight.
Yes.
Yeah. Okay. Yeah, we can discuss.
I'm taking the 4:21 a.m. train tomorrow morning, so I don't know why I chose that in retrospect, but yeah, I did. So.
I think part of the reason that RPA thing is definitely going to help you.
Yeah.
I don't think it's enough, but I think the amount of extra work to do like the isolation thing may be minimal once you have RPA.
Okay, you know, I agree. We find that, I mean, for a lot of builds do a very good job using like -WL and stuff, but we still, in about 5 to 10% of the cases, we end up doing a bit of patch elf, you know, after the facts to help with that, because sometimes there is sort of baffling something's been overlooked.
Yeah.
You know, but that would be awesome. Now, obviously, there are some tools like Load R needs its own build environment. It needs to be consistent with the group of packages it's working with. So, you know, but even with an R loaded, I'd like to be able to load like SAM tools and not have that conflict with anything else I've got loaded to run on. But anyway,
there's probably stuff we can do there. Okay, cool. Good. Yeah, thanks a lot. If you have any questions for Douglas, please talk to him over dinner or in one of the breaks. We'll switch over to Luca.
Okay.
And while Tal is working on getting decent Wi-Fi so he can give his talk. I think he's back in the Zoom already.
Yes. Yes. Yeah. Yeah. Oh, yes, of course. Thank you. I didn't take it back.
Yeah.